Chapter 4 now is quadratic equations. We start the new chapter. What exactly quadratic equation is? You are already familiar with quadratic polynomial, right? I write one quadratic polynomial. For example, x square plus 7x plus 10, a quadratic polynomial. Okay? This polynomial, if I equate to 0, now it become equation. What kind of equation? Quadratic equation. Okay? Quadratic equation. When an equation is called quadratic equation, if this is the quadratic polynomial equated to 0. So if a polynomial, a quadratic polynomial equated to 0, that becomes quadratic equation. This is what the meaning of quadratic equation. Should be of degree 2. That is why you call it as quadratic. Okay. So now what exactly you are going to see here is a general form. The general form or the standard form of quadratic equation, if you are familiar with the standard form of quadratic polynomial. This is your standard form of quadratic polynomial. When equated to 0, it is becoming quadratic equation. Here this A, B, C are any real number like a 1, 7, 10, any real number. But this should not be 0, okay? Here A, B, C are real numbers and A should not be 0 because A 0 is also real number. This is 0, then x square term won't be there. X term and constant term are 0 no matter. X square term should not become 0. Then only it will remain quadratic polynomial and the equation become quadratic equation. Many equations we can write here 4x square plus 7x equal to 0. If constant term is not there, still it is quadratic equation. See now is x square minus 9 is 0. X term is not there. This is quadratic polynomial, so the whole thing is quadratic equation. So we can write many examples for that. So you will write down this definition. Any equation of the form Px is equal to 0 is called a quadratic equation if P of x is a quadratic polynomial. Standard form ax square plus bx plus c equal to 0, where a, b, c are real number, a not equal to 0. Some examples have been written over here. Next is you go to the exercise question. Say you are given exercise 4.1. They have given some polynomial, some equations, okay? And you have to check they are quadratic equation or not. For example, they will give you equation like this, x square plus 4x plus 9. Instead they give x into x plus 4 like this. Your work is to check this is quadratic or not. You completely simplify. So what is happening now is x square plus 4x plus 9. Inside I open the bracket. Again x square plus 4x coming. Okay. This is 14x you take. 14x that 4x you write. No problem. So you will get this x square term getting cancelled. So it is becoming linear now. Only x term is there. X term and constant term. If you transpose it become 10x plus 9 is here. Linear. So you will tell this is not quadratic. So when an equation is given, you completely simplify. Is it of degree 2 or not? You check. Then it will be quadratic. Okay. Sometimes they will give you like this: x into x square plus 1 equal to 18. So you check it. Becoming x cube plus x is equal to 18. The cubic it is, not quadratic. So you check that which is quadratic and which is not quadratic by this way. So you will do exercise 4.1, question number 1. Then you are just checking, completely simplifying and telling that this is quadratic or not. This you have to do by yourself. Okay. Next we will see that. Next is how to frame quadratic equation for the given situation. Means which situation leading you to form a quadratic equation. Shall take some situations where we need to apply quadratic equation. Now you can take one question from your textbook only or any question. For example, you are given, okay, length of a rectangle is 4 centimeter more than the breadth. They give like this. Length is equal to 4 centimeter more than the breadth. Okay, they give like that. And the area of rectangle, they have given you 45 centimeters square. 45 centimeters square. So you need to find out what is the length and breadth in this situation. So you make the statement here. They always give one unit in terms of the other. So you don't have to take here x and y. So which dimension given in terms of the other you check. Suppose length given in terms of the breadth, you take breadth as x. Any one variable, x or y. And length will be 4 more than the breadth. Like that you can write one in terms of the other. So in this, I am given length is equal to 4 more than the breadth. So I will write here, let the breadth, I take x units, centimeter in centimeter, x unit I have taken. So length will be 4 more than the breadth. So x plus 4 centimeters. Okay, breadth is taken as x, length will not take y. Directly their relation between length and breadth will be given. So you write length is equal to means 4 more than breadth, x plus y. Now next you go to the area. This makes you the equation. The area, you know, area of rectangle, they have given you 45. So length into breadth is 45. A rectangle, okay? So it becomes x into x plus 4 is equal to 45. Okay? So opening bracket is equal to 45, then x square plus 4x minus 45 equal to 0. Get the equation. So this situation leading you to frame quadratic equation. Like that, you will be given the situation and you have to frame the equation. This is what next. You are not going to solve and you are not going to find out what is the value of x and y. This is not discussed in the question coming under exercise 4.1. Only framing. And why we have to frame? Because we need to find length and breadth. So they will give you a question. Frame the equation so that the length and breadth need to be could be found like that. Okay. So using that you can do question number 2. 1 or 2 questions from your book I will discuss with you. For example, exercise 4.1. You can do first question as we discussed. Question number 2. Second bit I take. Some bits we take. Some you do. See this question also. The question says, the product of two consecutive positive integers is 306. We need to find the integers. So we have to form the equation. The question says in the beginning, represent the following situation in the form of quadratic equation. Okay? And we need to find the integers so that we form. For that we need to form the equation. Question asks you only forming equation. They say consecutive positive integer. You take the, any integer, let the integers be. Alright, here is one integer I take, first integer x. Okay? The second integer will be x minus 1 or x plus 1. Consecutive. So like 8 and 9. Okay? Or 7 and 8 like that. So I take where positive, so this is that x and x plus 1 I take. These are consecutive positive integer. Okay? Now they have given you the product is 306. You are multiplying this 306 coming. Once you multiply only it will become quadratic and your equation will be ready. So next is given, what is given you write, the product is given to be 306. 306. So that is x into x plus 1, 306. Okay. So x square plus x is 306, bring here equal to 0. So equation is ready. Framing equation. Like that other situations also given. One more we discuss, the other you do. So first bit you do by yourself, you second bit here. You write all the steps, okay, and do it. We discuss with you one more bit. Question number 3 in 1 in exercise 4.1. Question number 2, third bit. You see, Rohan's mother is 26 years older than him. So, the product of their ages 3 years from now is 360. We would like to find their ages presently. So frame the equation. This is the question. Not asked to find the ages, okay? So you take the ages, son's age, you take son's age, son's age, X you take, because mother's age is given in term of son's age. So mother's age will be, mother's age 26 years older, 26 more, so X plus 26. Okay, these are the ages presently. These are the ages presently. Now the question talks about the product of their ages 3 years from now, 3 years later. So what is the product of their ages? So 3 years later, what will be son? Later. So son will be here, now he is X years old. So 3 years later, it will be X plus 3 more. At the same time, mother will be 3 more here. So X plus 29. Okay, this is her age 3 years from now. The question talks about the product of these two ages, not the present ages. These two ages product, they have given 360. So as per the question right here, these two ages if I multiply means the product becoming X plus 29. This is 360. This is completely multiplied. Make quadratic, write it in the standard form. This work is left to you. Okay. Now the next bit we discuss with you. Few bits we discuss. One we are going for solving. You will be getting more question to frame the equation by yourself. Right? So now look here. A train travels a distance of 480 kilometers at a uniform speed. So distance 480 kilometers. Speed not known, uniform speed they give. If the speed had been 8 km per hour less, means if you reduce the speed by 8 km per hour, it will take 3 hours more to cover the same distance. We need to find out the speed of the train. Okay? So what do you need to find out the speed of the train? Take it as X. Let the speed of the train. Okay? Actual speed. Speed of the train. Take X km per hour. Speed of the train is X km per hour. Okay? So this is the distance, this is the speed. They have given you talking about the time. So you make the time ready. Time, actual time. Actual speed is given. You are taken as X, actual speed. Now actual time taken, how much you write first. You know that is distance by speed is time. So you get here 480 divided by X hours. This kilometer getting cancelled, become hours. This is actual time taken. Now there is some alteration in the speed. The speed is reduced now. You reduced speed. They say that if the speed is 8 km per hour less, means you are reducing the speed by 8 km. Actually it is X km per hour. So you are reducing, subtracting 8 from that. So new speed is X minus 8 kilometers per hour. Okay? This is the new speed. Distance is not changing. It's a new time you make it ready. And they are comparing the actual time and the new time. So you make here new time ready, new time taken. You will have to use the same distance but new speed. So that is 480 divided by X minus 8 hours. This is the new speed. Original speed is 480 by X. New speed is 480 by X minus 8. Now this is the difference in this time. If this is taking the new speed is 3 hours more than the actual speed. Mean this is 3 hours more than the actual speed. Otherwise you can write what? The difference in time. Okay? Difference in time taken. This is 3 hours they give. The difference in time means, no, this is more. They say this is greater than this. So this new speed minus actual speed. That is 3 hours. So when you are writing the new speed minus actual speed, you will absolutely get in the equation. So as per question, okay, new speed, can write some steps like this, minus actual speed, this is going to be 3 hours, 3. So like here is 480 by x minus 8 minus 480 by x is equal to 3. Okay, now you simplify, frame the equation. This 480 transpose, take it out and go for simplification like this way. And you can divide by 3 also, complete. Okay, the equation will be more similar. You take LCM, 480 into x, and this will multiply here, minus of x minus 8 divided by x into x minus 8. You get 3, can transpose other side, or this can transpose here, or divide by 3 throughout, whatever. I divide by 3 both sides. So again here is 160, and inside the bracket is, if you open the bracket, the x will get cancelled. You get in the numerator 8, okay? When you open the bracket, x getting cancelled, this becomes 8, denominator becomes, open the bracket, x square minus 8x. Other side, when I divide by 3, it is 1. So both the sides I divide by 3. 480 by 3 here, 3 by 3, 1. So now you can transpose it other side. 160 into 8 here, x square minus 8x. This is becoming what here is 61, 1 to 8, 0. And this is x square minus 8x, transpose equal to 0. Equation ready, like that way. So you have to frame the equation in this way. Only framing, solving not required. This much you have to complete in your book up to 4.1 completely. Next you will see is solving equation. That is in the next class.